This is a how-to for chemical equations. To write this word equation into a chemical equation, you must first read it and analyze it. Powdered copper 2 carbonate mixed with aqueous sulfuric acid react to form solid copper 2 sulfate plus liquid water plus carbon dioxide gas. To write this in the form of a chemical equation, write the symbols for the elements and then look for keywords. Reacts to form stands for an arrow, for the arrow or the equal sign. The words plus and mixed with stand for the plus sign. And then the letters S stand for solid, L for liquid, G for gas, and aqueous stands for a compound that is in a solution. Okay. Now that you know the keywords, you must put them into the equation. So the plus sign goes where the words mixed with was, and the arrow goes where the words reacts to form were. Next, we will analyze the reaction patterns in this equation. So, as you can see, this is a decomposition reaction, and it can be identified because a compound broke down to form a new one. Oxygen split into a carbon dioxide atom and a water molecule. As you can see here, this has 3 oxygen molecules, and when it reacted, it split into a carbon dioxide and a water. A replacement also took place when sulfate switched from its place next to hydrogen and switched next to copper. Spectator ions can be identified in this chemical equation. Copper is one of them because it can be identified as a spectator ion because it does not affect the equilibrium of the equation, as well as sulfate. They are both equally present throughout the reaction. So if you wanted a net ionic equation, you have to cross them out. So copper is here, and it is equally present, as well as sulfate, which is here and here, equally present. Next, we will analyze the oxidation states for elements on their own. Copper, it is given in our chemical equation that it will act as an oxidation state of +2. Since it is a transition metal, it is unknown what its oxidation state will be. Carbon is in group 4, and group 4 tends to have an oxidation state of +4. O is oxygen, and it is in group 6. Therefore, it has an oxidation state of -2, because it is missing 2 electrons to be happy and to have a full electron shell to complete the octet rule. H is in group 1 and has a state of -1, and S is in group 6, and as well as oxygen, it has a state of -2 because it is missing 2 to have a complete octet. Next, we will analyze and identify binary compounds in this equation. We can see a type 2 compound because it has a transition metal, which is copper, and its oxidation state has to be identified because, as you could see in the written equation, it said copper 2. Since in transition metals the oxidation state is unknown, it has to be indicated, which is a great way to identify what type of compound it is. Next, we found a type 3, and it can be identified by the indication of the number of atoms in the names such as mono, di, tri, and tetra, as could be seen in this equation when we looked at carbon dioxide, because there were 2 oxygen molecules. We also saw polyatomic ions, which can be identified by looking for the special names given, as these have to be memorized. The polyatomic ions are a group of atoms covalently bonded whose overall charge is not equal to 0, so this is basically a compound with a charge. And this polyatomic ion found here stands for sulfuric acid. Since we have a lot of compounds in this equation, we can analyze the type of bonding in each of them. So, the type of bonding can be found by finding the difference in electronegativity, which means subtracting one from the other between the two elements that are involved in the compound. So, this is an example. In carbon dioxide, the electronegativity of oxygen is 3.5 and the electronegativity of carbon is 2.5. So if we subtract them, we get an electronegative difference of 1, which means it is a polar covalent bond. This is caused by the electronegative difference. So, it is called an ionic bond if the difference is greater than 1.9. For polar covalent, that number has to be between 0.4 and 1.9, so between ionic and covalent. And to be identified as a covalent bond, it has to be less than 0.4, the electronegative difference. So, for the compounds involved in this equation, if we were to analyze the electronegative difference of each of them, we would basically get that copper carbonate is both covalent and ionic because of the polyatomic ion involved. Since polyatomic ions involve a covalent bond, then it has both type of bonds. Sulfuric acid is a covalent bond, copper sulfate is an ionic bond, and water is a polar covalent bond. And all of this is caused by the electronegative difference of the two elements involved in each compound. Next, we will see conductivity. Conductivity is a material's ability to conduct electric current. So, for example, which compound will have better conductivity? When dissolved in water, those identified as ionic bonds will be better conductors because when placed in the solution, their molecules will dissociate into charged molecules, carrying a current very effectively, a lot more effectively than a covalent or a polar covalent bond. So, in our equation that we had today, we could see that these two were the best conductors of electricity because they are both involved in an ionic bond. Thank you for watching our chemical equations how-to.